Hello everyone, welcome to our tutorial of TransCAD. I'm Danny. This tutorial is designed for the course of Transportation Demand Models at Northeastern University, Boston. TransCAD is an industry-leading and also industry-standard software for travel demand modeling. It can implement four-step approach in a GIS context. For the tutorial today, we will learn some basic GIS visualization functions and explore some geographic data using TransCAD. Eventually, we will calculate the shortest travel time for a 12 by 12 little OD matrix as an exercise. Before we start, just for your information, other than watching tutorials, you can also teach yourself by clicking Help, and then here you can get a PDF user guide. Also, if you have questions on some buttons or functions in TransCAD, you can just use your mouse to hover over it and then press F1 so that you will get a helpful menu. So let's begin. First, we will do Open File, and inside this tutorial folder, we have quite a lot of files of different types. So the file type we're going to open is a geographic file. So over here, we can choose the type geographic file. In TransCAD, it is either a CDF file or a DBD file. They are both standard TransCAD format of geographic file. So we choose that. And the file I want to open is called FL Zone. So we open it. This is a little map of this place called Flintbury, and we have 12 zones for it. These zones are called TAZ, or Transportation Analysis Zones. So we can, just like other GIS software, we can use the info button to click on an object, this polygon, to visit its corresponding data. And we can close it and come here to put our cursor back to the pointer mode. As a matter of fact, we can view the data table behind all these zones. We will do that by clicking this button, New Data View. Now here's the table. We have 12 rows for these 12 zones we have, and the columns, which are called fields in this TransCAD context, we have for each zone the ID, the zone name, which are numbers 1 to 12, the population, the number of households in the zone, and some gender, age, and other demographic information. So that's the data we have. And with this data, we can do some visualization on the map. Let's say that we want to create a thematic map for the zones using the population. The larger population, the darker its color will be. So we will go to here, color theme map, wizard, and here, field, we can choose the column or the field we want to use for the thematic map, and we will choose population. And automatically, it creates 8 classes of colors for the painting, which you can find in the Styles tab, from lighter to darker green. That's the default color. And we can just click Apply to see. It looks good. We're happy about it, so we can click OK. So now it's the thematic map. And now let's do something more. For each of the zone on the map, we want to write down their names on the map, which is called label. So we go to here, the button of labels. Here we choose the field by which we'll label them. So here we would choose this field of zone, which is the number 1 to 12, and we apply. And it's kind of looks terrible because the labels are green, which is hard to see on the thematic map. So over here, we can change the style for that, for the labels. We can first make them black and then maybe make them bigger. We can even do something like change a background. We can create a halo, a white halo background for it, so it will be easier to see them. We apply, and now there's the new label for us. And we click OK. If you want, you can also use other things to make the label along with zone. So you can do that by, in the field, you go all the way down to multiple fields. And let's say we want to label zone. We also want to label their population. So we will choose population, which is here, and we click OK. And for color 1, that's for zone, we'll use black, and for the population, let's say we use red, and OK. Apply, and OK. Now on the map, we can see that, for example, zone 5, it has 55,000 people in the zone, and also other zones. This legend can help you read the thematic map. So that's for our little visualization. And now let's clean this visualization to make the map cleaner for our further work. We go back to the thematic map, click remove, and we go back to the label and remove. Now we're back to this empty map with the zones only. Alright, so now let's add the layer of streets, because that's obviously important for traffic. We will do that by clicking this button, map layers, and do add layer. So here we will add or open another geographic file. The file I'm going to open is called FLST, which means Flintbury Street. And we click close. Now here we go. Now we can see that we have this layer of Flintbury streets, which on the map are these gray line segments. And at the same time, we also got a layer called Flintbury nodes. And it's now invisible by default, so we can make it visible. So there are these black little dots on the map. They are joined or connected by these links we have. Alright, so now let's make it invisible again. Yeah, and for the streets, now we're going to open the corresponding data table. One thing to be noted is that this drop-down box, it shows us the working layer. So the current active working layer is this Flintbury Street layer, which is what we want. So when this layer is active, we click the new data view, we will get the table for the streets. Otherwise, if we choose the zones back as the current active layer, then when we click this button, we will get the table for the zones, not the streets. This also applies to a lot of other functions, so please always be aware of which zone or which layer is active right now. So we switch back to streets and click this button. We have our data table here, and again, each row is a line segment or a link on our map, and we have their ID, we have their length, and the name and the zip code, all this geographic information. And that's all. We don't have a lot of traffic information, which is needed for traffic analysis. So for this little example, we actually stored the traffic information for all these streets in another file, which we can open now. To open the file that contains those data is a binary file, which is basically a table, and it's called Flintbury Street Data, I think. We open it, and now this table, we can see each row is still the streets on the map, and we have information like lanes, parking, and capacity, travel time, and speed. This will be useful for traffic analysis. And now we have two tables for streets, which is kind of confusing. But actually, if we sort the two tables by their ID, we choose the field of street ID for the new table and do sort increasing. And we come back to the original street table, choose the field of ID and do sort increasing. And then we put the two tables side by side. Then we can see that the ID are actually the same. So this means that the two tables are describing the same streets on the map. So now we can actually merge the two tables together. They're back here now. The way to do that is data view and table join. So here in this dialog box, we choose the joining from which table. We choose Flintbury Streets and join table to another table, which is already here, Flintbury Streets data. And very smartly, TransCAD already found the identifiers inside the two table. In the Flintbury Streets table here, the identifier is this field called ID. And in the other table, the field for the identifier is this called street ID. So TransCAD will match the two tables row by row using this common identifier and then merge them together. After that, it will create a new data view, which name will be this. You can change it if you want. I will keep it and do OK. So this is our new table, Flintbury Streets plus Flintbury Street data. We have everything here, the ID length, zip code, name, and go to the right, we have the traffic stuff, lanes and travel time, speed things. Alright, so this table, we will need it later for our travel time calculation. So now let's go back to the map and let's look at the layer of nodes. We can bring it back. And also, very importantly, change the active layer to be the nodes. Alright, so here we can see a lot of nodes, which are mostly junctions in our traffic network. But actually, some of them are not. So we can open the data view for the nodes layer. And we have there, for each node, the ID and its coordinates. And this field called centroid, we can do sort decreasing. And we can see that 12 of the nodes have a value for the centroid field from 1 to 12, and all the other nodes have a missing value. So these 12 nodes are actually the centroid of our 12 traffic analysis zones, which means that they are the conceptual node. They are not the actual junctions in the network. And we should obviously treat them differently. So come back to the map. We can select these 12 centroids. We can do that by here selection and select centroids. Here we will need to choose which field TransCAD will use to select that centroid, and it's very smart. It already picks the centroid field to be the field, and we click OK. So now on our map we can see 12 of the nodes are changed. We can zoom in a little bit. You can see that they are now highlighted with this big red circle, and the links connecting it is also changed. So what has happened? If we come here to the display manager and open the subset of Flintbrand nodes set, we can see the subset of centroids that is created by what we just did, selection, select centroids. So it select the 12 nodes as centroid because their centroid field is not a missing value, and automatically it highlights this selected 12 centroids with this circle. And if we go to the streets here, we also open its subset. We can see this connector subset. These connectors are this dashed orange line here. They are called connectors because they connect our centroid of the TAZ to some nearby junctions. What that means is that these connector links are not real links. They're not the real roads out there in the network. They're just conceptual connector to connect our centroids so that our trips to be generated will find their way to get into our network. All right. So now we have the 12 centroids ready, and our target is to calculate the shortest travel time for the 12 by 12 OD matrix. We want to know the shortest travel time given this network from each centroid to all the other centroids. And before that, we can open another file, which is a matrix file here, which is matrix, and FLOD. This is a little table, a matrix table that shows us the OD flow of these 12 centroids. And here we can see the label is actually messy. They're not zone 1 to zone 12, but using these large numbers, which are actually the ID of the centroids. If we come back to, we click Window and come back to the data view of the nodes, we can see that, for example, centroid number 1, its ID is 31370, which is, come back to the OD matrix, which is this. So this one is actually zone 1, the centroid. So we may, just for our convenience, we may want to change these labels from this ID to our zone name 1 to 12. So we can do that easily by matrix and labels. Here is the dialog we're going to use as reference. So we say that we will use the data view of Flintbrand nodes as our reference table. And if we see a number here in the field of ID, we will label it with the value we find in the field of centroid instead. That's the logic. So we click OK, and now the labels are changed from 1 to 12. That's our 12 zones. All right. So we can leave this OD matrix here. We'll use it later. And now we have our 12 centroids selected, and we have all these links and nodes, and we would like to calculate travel time. So here, a very key step before that is to create a network. We can do that by network and create. This step of creating network is not very straightforward to understand, and it is also easy to forget, but it is very important and cannot be skipped. So what we're doing here is that given all these links and nodes as geographic object, on top of that, we create a file called a network file. And what's different from the network file from the links and nodes is that we can apply some traffic management policy on top of it. For example, if we only have the links and nodes, then if a car, for example, is traveling from this link and turn left to here, that's naturally possible. But in reality, we may say, for whatever reason, that left turn is prohibited. So something like that, we will be able to apply in the network, so that for later analysis, TransCAD will know that this left turn is not possible, and everything will be changed based on that. So that's just one little example. And for our case here, we assume we don't have any special management like that. So we will just create the network by leaving all these things as they are. Here, we only need to choose link fields and add this field of travel time. So what we're doing here is that we're sending this field of travel time of our Flintbury Streets layer to this network file we're going to generate. And with the travel time, it will be able to calculate travel time, the shortest travel time later. We just click OK here, and we can give our network a name. So I'll call it my network, and I'm going to overwrite my original file. Alright, so now the network file is generated. You feel like you didn't do anything, but you have actually done a very important thing. In here, the status bar, you can actually see that my network.net, this file just created, it is active. So only with this can we go further to calculate the shortest travel time. We will do that by network paths and multiple paths. And here, the shortest paths, TransCAD is asking, what do you want to minimize in terms of shortest? So the options are the length or distance or travel time. So we choose travel time. And here it's asking which central or which nodes do you want to use? Do you want to use all features? That means all the 1700 nodes we have, or this selection, this subset of 12 centroids only. And of course, we want to choose the centroids. We want to calculate travel time from centroid to centroid because that's what we're interested in. And here it says store result in a matrix file. So we click OK. And here we can, here's the place we're going to store the output file. Here we can give it a new name. Just call my shortest path. and I'll overwrite my original file again. And very quickly it's done. We can close this report dialog. And we have this new matrix, 12 by 12. And again, these labels are not what we wanted. We will change this matrix to number 1 to 12 again by matrix labels. We do all the same thing using Flintbury nodes table as the reference. We'll change the values in the field of ID with the value in the field of centroid. So this is our result. This is the travel time, shortest travel time for the OD matrix. For example, from zone 4 to zone 10, the shortest travel time given this network is 20.72 minutes. So this is a nice result, but we can do something even more. Let's say that bring back our OD matrix. For each OD pair, now we have the flow from zone 4 to zone 10, for example, we have 3 trips. And here we know that the shortest travel time is 20.72. So we can multiply these two tables together so that we will know for each OD pair the vehicle hour traveled, which is called VHT, an important metric for traffic analysis. Assuming that everyone will follow whatever shortest path here we have, so that they will have this shortest travel time. So we can build this new matrix we want on top of, say, the Flintbury OD matrix. We can do matrix. Make sure this matrix that you are currently opening is active here. And then you do matrix contents. Here we add a new matrix. And we can rename the new matrix as VHT. And close. Now the new matrix VHT we created is actually sharing the same window with our Flintbury OD flow matrix. So under the window tab, they're both here, but in the dropdown, you can select that VHT. So of course, it is an empty matrix because we just created it. We didn't fill anything in it. So now we can fill the contents by matrix fill. Here we'll go by formula. We say each element inside this new matrix will be equal to that corresponding element in the matrix of flow times the value of the table of shortest path travel time, which is here. And note that this unit is minute, so the final result we want is in hours. So we do divide it by 60 and click OK. And now we have the value. We can do a quick check to make sure it's correct. Again, from zone 4 to zone 10, travel time is 20.7 minutes, and switching back to the flow matrix, we have 3 trips. So 20.7 times 3, that's 62 something. Back to the result, which is 1.04 hours. So that's correct. So this will be our final result for the OD pair, the vehicle hour traveled. And you can save this result as another matrix file. You can also export it as a CSV file so that you can do further analysis in other environment. You can also print it, and you can also make something fancier called a layout. You can do that by File, New, and choose Layout. A layout is like a collection of the maps and tables, like making a little poster. So we can add elements by this button. We choose this rectangle area to add our map, and we choose this area to add our final result of VHT matrix. And you can maybe give it a title of my analysis, and you can use the pointer to click on it and zoom it, relocate it. You can do the same for other elements as well, so that you can print this as a poster or do whatever report you need. So that's all for our tutorial today, and see you next time.